Hey everyone, and welcome to The Explainer. I am so incredibly excited to get into this one with you today. If you're really focused on understanding exactly where technology is heading, you are absolutely in the right place. Today, we're breaking down a massive shift in the tech landscape. We are going to look at how artificial intelligence transitioned from being this, experimental software into hard, physical, and highly regulated infrastructure as of mid-2026.
Okay, let's dive into this. The contrast between just a few years ago and today is honestly pretty stark. Back in 2023, AI was all about experimental chatbots and these little proof-of-concept software pilots. It was fascinating for sure, but it was really still finding its footing. Fast forward to today in 2026, and we're living in a completely different reality. AI is now core infrastructure. We're talking highly lucrative physical hardware, massive biological research platforms, and serious legislative frameworks. We've officially moved out of the sandbox and into the foundation of the global economy.
To understand this evolution, we're going to climb what we call the AI stack. We'll quickly cover 1. OpenAI's custom silicon play, 2. The rise of agentic CPUs, 3. AI's multi-billion pharma deals, 4. Rewriting the AI rules, and finally 5. Enterprise AI's ROI engine. Let's get started. Starting us off at layer 1 of the stack, section 1, OpenAI's custom silicon play.
So, the AI hardware race has a major new contender. On June 24th, 2026, OpenAI, the company running the most used AI product on the planet, and Broadcom officially unveiled their brand new custom AI inference processor. They're calling it Chilapio. And this isn't just some modified graphics card. It was architected from the ground up specifically to run large language models at production scale. But look at its development cycle, 9 months. They essentially gestated a revolutionary piece of custom silicon in the exact time it takes to have a baby. Moving that quickly in advanced semiconductors is practically unheard of. What makes Chilapio so special is that its architecture reduces data movement bottlenecks. Most slowdowns don't actually come from raw compute limits, but from constantly shuffling data back and forth between memory and processors. Chilapio balances all of that in a single design, and early lab testing shows it's already successfully running actual workloads, including OpenAI's current Codex models. So the crucial point is, what does this spicy little chip actually do? It focuses entirely on inference. Now, inference is the act of running a trained model to actually generate responses. It's very different from the initial training of the model, which takes those massive, warehouse-sized data centers. Inference happens every single time you type a prompt and get an answer, making it the dominant cost driver in AI infrastructure right now. Whoever controls the specific hardware layer basically dictates the entire economics of an AI business.
And the business case here is absolutely massive. Alapino is projected to cut current state-of-the-art GPU inference costs basically in half. When you're operating at the scale of OpenAI, managing tens of millions of daily users, cutting your dominant cost driver by 50% is a staggering financial advantage. Plus, it reduces the reliance on third-party hardware. They're targeting the initial deployment of these chips by the very end of 2026.
Let's move up the stack and see how this builds. Section 2, the rise of agentic CPUs.
Now, when most of us think of AI chips, we immediately think of GPUs, right? But GPUs are built for parallel matrix math. They are fantastic for training models, but actually pretty bad for autonomous agent-driven AI. Agentic AI needs fast, sequential reasoning. It's essentially high-speed logical context switching and continuous decision-making loops. That kind of work runs far better on a CPU with incredibly high single-thread performance. And that is exactly why Qualcomm just unveiled the Dragonfly C1000, a massive 250-core server processor. Based on the Osrion architecture, it boasts sustained frequencies above 5 GHz and features like PCIe Gen 7 and CXL memory. CXL essentially gives the CPU this massive, high-speed, short-term memory boost, so it literally doesn't lose its train of thought. Qualcomm claims it delivers double the performance per watt for these agentic tasks compared to the leading server CPUs.
And trust me, the industry is paying very close attention. Meta's CEO actually showed up at Qualcomm's event, officially committing to deploy the C1000 for Meta's server infrastructure by the second half of 2028. That is a massive endorsement. Right alongside this, Qualcomm announced a $4 billion acquisition of a software company called Modular. Modular lets developers write AI apps once and run them across all sorts of different chips. So this is a direct, multi-billion-dollar bid by Qualcomm to completely own the agentic compute layer.
Moving right along to layer 2 of the stack. Section 3, AI's multi-billion pharma deals.
So you might be wondering, what does all this raw compute power actually buy you in the real world?
Well, it buys landmark pharmaceutical breakthroughs. AI is no longer just a tool for accelerating drug discovery. It has actually become the core engine of some of the largest pharmaceutical deals on the planet. Just look at the recent BIO 2026 convention, which showcased a collaboration tackling neuroimmune central nervous system disorders. The total potential value? $2.5 billion. This is a massive deal between in silico medicine and South Korea's SK Biopharmaceuticals. AI-first drug discovery companies are no longer just pitching their potential. They're signing massive contracts based on demonstrated performance, with this particular deal starting with an upfront payment approaching $20 million. And this brilliantly illustrates exactly how this tech is being applied. In silico brings its generative chemistry platform, pharma.ai, to the table, and the AI spans the entire early discovery pipeline. First, it validates the biological targets. Second, it generates completely novel molecular candidates from scratch. And third, it optimizes those molecules for both safety and efficacy. It dramatically compresses a process that traditionally takes years into a timeline measured in months. After that, SK takes over the clinical trials and commercialization. It really is a perfect synergy of AI speed and pharmaceutical scale. Pivoting over to Layer 3, the friction of reality. Section 4, rewriting the AI rules.
Now, as AI hits the real world, it inevitably hits legislative friction. There is a massive tension right now between consumer protection against opaque algorithms and the heavy pushback from businesses citing massive compliance costs and the risk of stifling innovation. Now, what's really interesting about this slide is how this just played out in Colorado. Their original comprehensive law, SB 24205, mandated heavy governance, annual risk assessments, and strict duty of care standards. But literally right before it took effect, it was scrapped. It was completely replaced by a significantly narrower, disclosure-based model, SB 26189. Under this new model, companies just need to notify consumers about automated tools, provide explanations for adverse outcomes within 30 days, and offer a meaningful human review.
So looking at the timeline, in May 2026, Governor Polis signed the new replacement bill, which completely bypassed the June 30th activation date of the old heavy governance law. The new, lighter disclosure model will now activate on January 1, 2027. Why does this matter so much to the rest of us? Well, because there are currently 78 different chatbot-related bills alive across 27 states, and we still have no federal law. Colorado's pivot from a governance-heavy framework to a disclosure model sets a major legislative template that other states are very, very likely to copy. Finally, we arrive at Layer 4, the macroeconomic bottom line. Section 5, Enterprise AI's ROI Engine. For the past 3 years, enterprise AI looked like a bunch of really cool experiments without much financial return. Well, that phase is dead. According to the Stanford Digital Economy Lab, 40% of enterprise software applications now embed AI agents as core features, not just optional add-ons. And if you want hard proof that the era of proof-of-concept pilot programs is completely over, look no further than JP Chase. They committed a staggering technology budget of nearly $20 billion for 2026, deploying a team of 2,000 employees dedicated entirely to AI initiatives. You do not spend $20 billion on a science fair project, right? You spend it on core infrastructure.
And here's exactly why they are spending that money. JP Chase is already reporting roughly $2 billion in operational savings. They're measuring 10 to 11% productivity gains across the board. They are seeing massive engineering enhancements and heavily advanced fraud detection. This investment is now literally self-funding its own infrastructure. AI has decisively shifted from being an experimental cost center into a massive ROI engine operating across complex enterprise environments.
Now, to be totally fair, it is important to acknowledge that barriers to adoption absolutely still remain. Only 20% of companies currently have a mature governance model for autonomous agents, which leaves 80% vulnerable or lagging behind. Furthermore, there's a pretty severe shortage of qualified AI engineers right now. Tech giants like OpenAI and AWS are also still actively trying to perfect what they call a stateful runtime environment, which is basically a way to give an AI a persistent memory, so it doesn't lose context while navigating complex corporate systems. The gap between a polished demo and a robust production-ready system is still very real.
Which brings us to the ultimate question you really need to ask yourself today. Are you treating AI as a future technology or an operations budget? Because from custom silicon to multi-billion-dollar pharma deals and massive enterprise ROI, the AI stack is solidifying right now. Treating this merely as a future strategy guarantees you will be structurally behind your competitors in just 2 to 3 quarters. The infrastructure is here. The only question is, will you build on it or be buried by it? Thank you so much for joining me on this explainer. Keep learning, and I'll catch you next time.